Hello, my name is Darren Newman and this is my poster on the determination of mechanical and biological impact of a beta-tricalcium phosphate reinforcement on a gelatin scaffold. Now, gelatin is used in tissue engineering as a scaffold due to the fact that it is bioactive and biocompatible. However, it is not sufficiently strong enough and doesn't have the sufficient physiomechanical properties to be used in bone grafts and osteogenic tissue engineering. Nanocomposites are often employed in tissue engineering to enhance the physiomechanical properties of scaffolds. In this poster, we are discussing the effect that a beta TCP nanocomposite will have on a gelatin scaffold, and we believe it will enhance the scaffold for viability of MC3T33E1 pre-osteoblast cells. So our materials and methods here, we have our test for the mechano-physical properties, which involves calculating the Young's modulus of the pristine scaffold and the reinforced scaffold, which we will determine using a uniaxial compression test with a Zwick tester. For the physical properties, we are calculating the swelling rate and the degradation rate, and for the biological properties, we are calculating the cell viability after a week's incubation period using a Hoist DNA assay and comparing it to a standard DNA curve. So we fabricated the composite by creating a 5% gelatin, 10% beta TCP solution in PBS and freeze drying it for a 26-hour period. So our results, here we have our result for the Young's modulus. As you can see, there's a large difference between that of the gelatin and TCP scaffold and the gelatin scaffold. We determined that there was a statistically significant difference due to the introduction of beta TCP to the scaffold. And so here we have the swelling rate results. The gelatin scaffold has a quite high swelling rate of 86.13%, which is a negative due to the fact that it would increase the degradation rate of the scaffold. There was an anomaly in our results, which was that the gelatin and TCP scaffold degraded. The degradation rate, however, after a week's incubation was equal for both of them, as they both degraded with a rate of 100%. And finally, for our cell viability after a week's incubation period, it can be seen that there was greater cell viability in gelatin and TCP reinforced scaffold than the gelatin scaffold. Again, we t-tested it and we determined that there was a statistically significant difference due to the beta TCP presence in the scaffold. So we can conclude that the introduction of beta TCP has improved the scaffold's physiomechanical and biological properties.